Here's a static equilibrium problem that looks too hard to solve. We're given a 400 kilogram horse leaning on a wall and given some, but not all, of the dimensions, just these ones. And we're asked to find a force exerted on the horse by the wall. But the only force that we know is the weight force, which is 4,000 newtons, using G equals 10. There are two other forces not shown, the support force from the ground, which must counteract the weight, and a frictional force from the ground which counteracts the wall force and keeps the horse upright. Static equilibrium means the sum of the forces is zero and the sum of the torques is zero. We can't do much with the sum of the forces because we don't know anything about the sideways ones. So let's look at the torques. Remember, we can choose our pivot point when taking torque balances, so we'll choose it to be at the hoof, so we don't need to consider friction or support forces in our balance, as their torques will be zero. So how are we going to find the torques from the two remaining forces? Well, let's have a quick reminder about moment arms. When we have a force of magnitude F that's not at right angles to the lever of length r, sometimes there's a shortcut to finding the torque. We can slide the force along its direction of action until it is at right angles. Then we can use this shorter distance, called the moment arm or the lever arm, or r perp, to find the torque, as torque equals force times r perp. And we can do this for our horse problem with both forces. We slide the weight force down until it reaches the ground, so it's now at right angles. The moment arm is 0.35 meters, and so the anti-clockwise torque is given by 0.35 times 4,000 Newton meters. And we slide the wall force across until it's at right angles, and so the corresponding clockwise torque is 1.2 meters times the wall force. These two torques must equal each other for the torques to balance, so 1.2 F wall is 0.35 times 4,000, which gives us F wall is 0.35 times 4,000 over 1.2, which is 1166.66 recurring newtons, which is 1200 newtons to two significant figures. We could then go back and use the force balance to find the other two forces if we wanted to.